Welcome again to our JPON conference and our online part. And our next speaker is Marco Schulz, who is an expert with more than 20 years of experience in enterprise development. So if you are developing like a huge enterprise project and it is poorly covered with tests and you have problems with this, I think you're in the right place. Am I getting this right, Marco?
Absolutely, Ivan. Yeah, thank you for the introduction. Yeah, really, I'm working there almost 20 years in really large Java-based web applications, mostly in DevOps, um, automation. Yeah, there is always testing a giant issue.
Okay. And
Um,
in the annotation for your talk, you mentioned that most often you meet projects with no single line of testing code. Is it true?
Absolutely, and as bigger the company, as less tests are available. This is something internal rule I discovered
Okay.
over the
And I
years.
believe that after you come there, they definitely have some tests.
Oh, I hope so. I hope so because this is something we really have an issue since more than 20 years, and since today, it's getting more easy to write tests than 10 years before.
Oh, yeah.
So,
With all the new techniques, of course. Okay, before we start, let me remind our listeners that you can ask questions on Telegram chat or on the chat on the website. So please don't hesitate to ask, and I will read them all, and I will ask them to Marco. And please, don't forget to like our talk. Don't forget to rate our talk. So, Marco, the stage is yours. We are eager to listen.
yeah, thank you, Ivan. Yeah, the point is, in general, how I organize the talk is as first I'm talking in general a bit about test automation. What is the difference between general test approaches? Then I'm going very fast into the things how we can do a very fast test automation setup, writing unit tests. Also, it's very important to see if the tests we wrote, if they are fine, because I mean, it's like a clean code implementation. It could work, but it works fine is another question. And after this, we have also a kind look into integration tests in our development lifecycle. This we will do with microservice, and just a short introduction how this could go. And of course, when we have to integrate infrastructure in our test set, so then test containers is a very new, interesting technique. So I will show you a little about this. Yeah, let's start. So finally, since the 1970s, we have something like 80% of commercial software development projects is still failing. And the question what that means, of course, you could think maybe they get interrupted and canceled, but it's not like this. At first, a project is failing when it takes too much time, when you pass the deadline too long. Another point is, of course, when the budget is exploding, when the cost increasing so much, then your project is failing too. That don't mean they get stopped, but finally, this could be a giant issue for you because the thing is you have to get done with this. Sometimes, if you want to introduce a new service in the internet or something, the deadline is something you communicate. This is really a huge issue. And the question is, why this is still a problem? So, like we already say in the beginning, yeah. One big thing is we don't really have a test automation. That don't mean software engineers or developers they don't test. They just do it in a very uncomfortable way, very manual. This we should avoid because finally we can speed up. One thing is when you start with test-driven development, you have to think as first maybe your code base is quite huge, some million lines of code, or maybe a little less. This is not so the big issue. And the biggest thing is don't start to write tests for the whole application. just focus in your implementation and write tests for your implementation, because you're aware of the problems there, you know what to test, and you can integrate this in your daily workflow. And the code base was working for some time without testing, so it will work too. When you have to go into bug fixing or something, then you can start to writing tests. And one thing that people always have as a giant issue when they start test-driven is this rule: test first. And well, you don't need always to go this top-down storage to write your test cases, even if you're not really familiar how to do that as well. Start bottom up, write your implementation, and when you have the implementation, then start developing for this implementation test code. So this is okay for the beginning, and then later, when you're familiar how the process is working, how the things are going fine, then it's not a big issue to change that really to the original idea of test-driven development. First write your test cases and then go into the implementation. So it's okay to switch this a little. Our setup in general will be, of course, an actual long-time support Java 17. I'm working here with the code is based on Maven 3.8 with JUnit 5, and optional, we have also Docker. This we will need for test containers. But with GDK, Maven, and JUnit, we are fine. So you can replace this kind of things too. If your project is working with Gradle, it's kind of easy to change that too. Or if you don't want to work with JUnit, there's other test frameworks you could use. No, for example, TestNG. The benefit of JUnit is just simply there's a lot of other environments you could use, like for test containers, like other things, testing your API with ArcUnit, and then they are based on JUnit, and it's very easy to run this kind of things together. So for that reason, if you start, I really recommend you go into JUnit 5. And as first, when you write unit tests, in Maven, there is the Surefire plugin we need to use. And in the test, our test files are marked in the way like foo test. So the word test as a prefix or a postfix in your class name will show Maven this is a unit test. And this will execute it by Surefire. One important thing is when you use the Surefire plugin, you should configure it to test failure ignore on true, because this is quite important in your development lifecycle. Because what happened there is simply your test is run or your build is running, maybe a test is failing, but this test is not the reason why the failure occur. This could be another test. And when you have this toggle in true, all the tests get executed, and then you get a result that shows you, okay, execution of 200 test cases, and 3 of them, they are failed. And then you can step through and search where is the problem. So for that reason, during the development lifecycle, keep this in true, and when you're doing release, you can switch that easily to false. Another thing is when you write code, you should write your code in a way that you're able really to write test, or that the code is testable. One thing we already see here in a standard implementation code, this is supposed to be a validation later, we need a return. When the method don't have a return, it's very difficult to test. Why? Because what the test framework is doing just, it's throwing some input into the method and checking the outcome of the functionality with an expected value. And if I don't have a return, like my functionality is void, then it's getting quite difficult to test that. There you need other approaches. This could be, for example, check if the complete object is changing somehow. So for that reason, a very good recommendation is when you write a code, start with a body like this. The first line in your implementation should be really the return value, the Boolean, give the variable. set it here, for example, as a false. This will be the default. Place this as a return. In this, then we are able to place our implementation. This will be not so dramatic. Here we are simply doing a regular expression match. That means we check the content, it matches for a regular with a regular expression. And when this is true, when the regex matching the content, then we change here our variable from false to true. This is so the standard. And here you see also in the else path, there is included a logging. So when the regular expression don't match, we are having here a log output in a log level warm, because it's not a mistake, it's not a failure. So we just should give an information, okay, the regex was not matching. In my case, I use in my projects usually logback as a logging framework. It's very easy to configure because you can have a configuration, especially for your test cases. And this will not deployed into production because it's called then logback minus test.xml. And there you can configure just the logging in a log level debug, that you get all the information. You don't need to write down in your code always there system print out ln and have to take care to erase this kind of things. I just write the output of the logging simply in the console. That's sufficient to do that. And then I see always where could problems occur. So here, remind, we have an if-else statement. That means our condition could be true or false. So for this, we have to write now some test codes. You see here, there will be our test class, validator test. Like I already mentioned, the test is binding the class or mark this test case as a unit test, and this will execute it by the Zofire plugin. And here we see, okay, the test annotation for JUnit. We are just simply testing the validation. And there we have the happy path. We place our variable Boolean called check and execute the validator with the validate method. Now, here we have the input of the content ABC with the regex ABC supposed to be our method or move to true. And this we will check here with the assert. The assertions in JUnit, there is different assertions we can use. One is as a true, as a false, or as an equal. Now that a value, expected value, is equal to the method return. Here we just check if our method validate returns on true, and when this is working fine, so the test is passing. But this is just a half of the work, because we have also the case when the validation is not working. So for this reason, we need a false positive. And finally, it's almost the same implementation. We just have to write a way that the regular expression is not matching with the content. Here, I'm just placing there the same in uppercase. What suppose that the validating method don't work and gives a false. And in this case, our test moves to as at false. There we see we already have two test cases for this little method. And one big recommendation is don't place these two tests not in one method, not in one test method, because when this is failing, it's very difficult always to investigate. Just test one thing in your test method. When this is failing, okay, then you know, okay, the method validate is failing, or fail validate was failing for some reason, and then you can investigate much more easy, much more fast about the problems they occur. So be aware of keep your test methods compact. They apply the same rules like for clean code implementations. Here I have a little overview how you could build your mental idea about how to write test codes. And this is the same also for integration tests. So the function, the implementation we have here in this corner supposed to have a return value, then it's more easy to test. The test method should cover the AAA principle. That means arrange, act, and assert. So what we see here is a bit, overwhelmed. So you don't need to do that completely, like you were seeing a few slides before. It's not so dramatic if you keep this a little more compact. But sometimes you have complicated test sets, so then it's not so bad to have it. So the arrangement is just simply prepare your test. If you have there some objects, they have to get created to fill. That is the arrangement. Then the act, of course, execute your test functionality, and the assert is then check if the functionality fits with the expectation. If you have this in mind, it's a quite easy thing to write test cases. There is not really a rocket science behind. The next question we have is how many test cases we could need. For this, we have something called complexity metric of McCabe. This is, in general, something really easy. The regular algorithm is just counting loops and iterations, add one, and then you have the, in general, amount of your test cases. So it's not really important that you really have for your functionality always the same amount of test cases like the McCabe metric is telling you. Sometimes you could combine their things and it's a bit less, but this gives you a little idea, okay, how many test cases I will need. Let's have a little look how this could be. Everybody is using always, there's something like is empty method for checking strings, if the string is null or is equal. So that means we have there the true when the message is not null and not equal. And the important thing is here our if statement. We have two expressions in the if statement, and we have to check both expressions to get a full test coverage. The thing is here, we have to write a test which is checking when the message here is null. And of course, we have to check the same when the message here is empty. So these already are two test cases. And then we have to test the opposite, of course, when this is not null. So because both of these conditions are able to enter here in the else path to give then the information. And the other two conditions is for the if path. So you need here, in this case, minimum two test cases for the assert true and the assert false. You can combine that in the assert, or you can split it up. This depends how complex is your functionality you want to test. In this case, is not really a big issue if you write there in one test case, if the message is null, the other check with equal 0, if this is giving assert true. The same then for the assert false. So and there you have a little idea what you have to take care. This you can see a bit more in detail, because we still have there something like, in Java, there is a tool called Jacoco, where we can measure the test and the branch coverage, or the line coverage and branch coverage. This tool is running inside of Maven in the Maven lifecycle, in the Maven site lifecycle. This is generating a report. One of here you see a little screenshot of the report, how this could look. If you want to get a bit in detail how this code and line coverage is working, may stay a little after the talk, then I could go there a bit more in detail with some live examples how this could work. In this case here, we already see in the line 217 and in the line 218. We have here marked as a red. That means the if statements, doesn't matter now what this method is doing, the if statements are simply not tested. They are not covered by our test cases. So we have to write exactly for this case, if not node get parent equals to check parent, and if not node get name equals check get node name. We have to write for this especially test cases, and then we are able to reach here the else path. So you see then when all the lines are reached, for example, here you could have the else path really as passed through, but here on top in 217 it's still marked as red. Then you don't cover all the branches, but you already have test cases. They helps you to enter in the else case, but they don't cover all the ways how to enter. So this is the branch coverage. To get here almost everything green, except in the if statements, you have the line coverage. And when the if statements are red, then mostly there's something with the branches. Sometimes when you're working in this way and you do this in your daily workflow, then you find out very fast, oh, there is some statements really I cannot reach. Doesn't matter what I'm doing, I cannot reach. This could give you the idea maybe this way of implementation is not correct, or I could reduce there something. And this is one of the benefits you have with test-driven development. If you use this every day in the way writing your code, writing for the code test cases, execute the test cases, check the line and the branch coverage, you really change the way how you code. The quality of your implementation is increasing dramatically. I'm doing this now since some years, and I have really the experience. I was changing extremely in the way how I write code. One thing you have to keep in mind too, when you're writing tests, that don't mean your application is free of problems or failures. Tests are just giving you an idea of a specific behavior, how the application or how your code is performing for these test cases. This don't mean it's free of failures. And sometimes, one day I was doing a little mistake. I was writing a test case for a copy a list. And one thing I was doing there was simply I was using there call by reference and not a call by value. And that means I was operating finally in the memory address. My test code always was passing very well, very green, but the test itself was not corrected. Finally, what gives me the idea that there is something wrong was a friend was watching my implementation and told me there is a mistake. So that means it's not a bad idea sometimes that your colleague is checking also your test cases, because you could do some logical mistakes. Well, it's getting executed and everything seems maybe fine, but it's not a bad idea always to have there in your test cases also a refactoring or a quality assurance. Another thing is, of course, integration tests. The most of the people are always thinking in integration tests into behavior-driven development using tools like Cucumber or JGiven. This, by the way, you can also combine very easy with JUnit. But in our case, we will use integration tests, for example, when we have there a microservice and we want to test during the development if the microservice works like we need. For that reason, we have to start a web server to call there the REST calls to see if the REST call is exactly given what I am expecting. And the biggest problem of this kind of things is they are very slow. They slow down extremely your implementation cycle. So in this way, we have in Maven the failsafe plugin. And the failsafe plugin is working with the integration tests. Integration tests in Maven, you can distinguish between unit tests. They have a prefix or a postfix IT instead of a test. So that means this kind of test classes will executed by failsafe when they end with IT or when they start with IT. So here is the same configuration like with unit tests with the Zurfire plugin. You should have also here the test failure ignore on true. In the case there is some collection of mistakes, you can see them incomplete. Another thing here I place is skipping tests, because integration tests in general should be deactivated in your daily process. If you're not working there on the integration test, you develop something, keep it deactivated, because really this slows down your build dramatically. This is why we separate integration tests of a developer from the unit tests. Usually integration tests are done by a testing team. They are using your artifact and see how artifacts they are getting integrated together to a whole application where you run their Cucumber or JGiven, test-driven, behavior-driven development. But in our case here, we are in the code and we run this exactly in our environment, and we want to see how it works. So one thing is, of course, we have here our microservice. It's just a standard microservice. It's not so important what this is doing. But what we see here is, of course, we have here an if condition, and we send a response status of OK to 200. Or in the case there is something not working, the object is not represented in the database, there is sending a not found, a 404. Or for some other mistakes, there is sending a 500. And of course, we want to check if these status codes are correctly used. This is why we really want to have this integration test in our code base, not as a separate project. That means we have to execute this microservice somehow. For this, we need an embedded web server. I use in my project Grizzly. You can configure with this code here to run it. This is just deployed to the test cases. This will be not available in your finally in your production code, because you mark the dependencies as a test, and also the code of the Grizzly server is in your test case, in your test side of the code. And then you have here the integration test, and you see in JUnit there is existing something, annotations before all and after all. And in the before all, we just set up the Grizzly server and we started. And when the Grizzly server was started as well, we execute here an assumption. And we say assume true when the server is started. And the thing is, when for some reasons the server could not start to less memory or whatever, then we have in our log files here REST server startup failed. And then we find out, okay, there is something in this way we could investigate, but is not, we don't need to search for some mistakes in our implementation. And of course, after all, we could say then shut down. Yes, you could now mention, well, this could be a bit too heavy, too long when these test cases get executed there, or when the server for every test set get started. There are some ways to improve, but I want to show here just how this is working with the before and the after all setup, that you can put their assumption, or if the database is present now, with this assumption, you can stop executing the tests when the preconditions are not matched. And here we see a little test case for this microservice how we check it. And this way is just to check if our account gives the status 404. Here you see what I always using is placing in the beginning of the test a little log output, what kind of test. So this I can grab later in the complete test output to see in the log file or in the log output where is exactly this part. Because you cannot easily manage JUnit to say, okay, this test case get executed like this. You have to do there a bit more, or you have to spread around there a bit more information, and this have a negative effect if you are orchestration, the methods, how they get executed, you're a bit far off parallel execution, and then everything slows down dramatically. So here in this case, I'm executing the account status 404. I'm just call there the microservice, and I storage everything in the response. The only thing I have to do later is check if the response get a status 404. And then if this happen, everything is passed. My test is correct. And this kind of test we have to write for all the other things too. Now, when we have there the 200 or the 500, we have to provoke this kind of things, how this could work. So let's show you this a little in the EDI, how this could look in real life, that you get a little idea how this is working. So this is my NetBeans. On EDI, we have here, for example, the role service. This is a microservice. The code you can find in my GitHub repositories. There is GitHub Elmar Dot. There's a repository called TPACL. There you find all these kind of things I'm talking here today. So, for example, here we have our class role service. We implement them. Fetch role, fetch project, protected roles. We see here always the status with log files and everything. And we have the corresponding test case. And you see here the test case called role service IT for integration test, because this test is just executed in the case you really have there an integration test, and this you can activate or deactivate by the variable I was telling you. One thing is here, you write your test. You can see here the before all. Here I'm checking if the database is present. Here I'm starting the Grizzly server. And the code for the Grizzly server, you could find here very easily too, when we move there to the ACL server. You see here in Java test, Java, and there is here the point application, ACL. We find there the Grizzly server. I place this a bit more up to have it present for all the submodules. When we open like this, it's a bit more easy to see. Test package. So here ACL, we see other sources, test sources, server, here test package. This and NetBeans here is the embedded Grizzly, is the same code like we were seeing here in the slide. This get executed here in the IT test case. And then I have here, after all, I shut down the server, and that's all. And then I can execute it here, a test file. And there you see, he is running down the test, the Maven, and this is all the logging. So when we want to get here test role 200, we just grab this, place copy. There, go here inside. Okay, it's not completely passed through, and here we see it's going quite slow. Yeah, the server starting takes a lot of time. And this is one of the things we really have to be careful if we're doing there a lot of things. So,
Marco, I'm sorry. Can I have a question? In your
yes,
in this example, you're also using a database, right? Via this
yes,
JDBC connection. And who provides this database for this test? Is it just assumed to be running, or is it a test
there's
container? Or
not in this case here, it's really fixed installed, but I have later a little example how to provide a database with test
okay,
containers.
got it. Thanks. Okay.
So in this way, you see here again, we should able to investigate there our log files to see where the things are passed. And you see one thing I'm doing here in the logging too is always in the constructor, I write a log message instant class. And this gives me sometimes a good idea how my objects get called. And this is just during the test case. And sometimes you get an idea, okay, this is a little much, and maybe I was doing a wrong call. Yeah, to optimize a bit the speed up of the application. One thing, maybe with a log back, I have here in other test sources, you see here, there is default package. You see here the logback test XML. This is the configuration you can use just simply, and this is not provided in the, finally, in the, how to say, it will not provide it in the application you put in production. It's just here when you run it in your EDI or in something like a CI server of Jenkins or something. Okay, let's move a little back to the presentation because we are running out of time and we have a lot of things to talk. So you were seeing here the integration tests, they are quite slow. One thing is like, was now having the question of how the database get provided. For this, we have something like test containers. Test containers need as first in your system a Docker installation. Without Docker is not working. And you have to secure that this Docker installation is able to download Docker container from a Docker registry. This could be Docker Hub or an internal Docker registry you host, for example, with tools like Artifactory or Sonatype Nexus. You can include, without any trouble, test containers in your test code, and this will also not provide it in production code. Let's see how this is going. As first, we need also some Maven dependencies. Here in our case, we are starting a Postgres database. So that means we need a test container Postgres. We have here the scope for test. That means this artifact is just during the test and will not be deployed into production. Another thing, of course, we need is the database driver for the database. Here in our case, Postgres 42.51. And if you're dealing with other types of databases or other infrastructure, keep a look on testcontainers.org. How you could finally, you find there a lot of test containers you can use. There's Redis, there's Azure. So there's a lot of things you can use. In our case now, we're just running there Postgres. The thing is here in our test case for the database, we have here the class rule. We start the Postgres SQL container. And the really difficult part is just here. The Postgres SQL container, there we define the Docker container we want to use. In our case, is Postgres 14. This you can investigate in Docker Hub now, what kind of containers are available. Don't place here something like latest. Always have a very defined container you're using, because if not, your test cases cannot, when there's changing something, they could fail and you're searching for a long time, what is the problem? Then create a database name, username, password, and this gives us now here the connection string, and this will be GBDC test TC for test containers, and then Postgres 14, and you have here GBDC test containers, and then Postgres SQL 14 is exactly that what we've written here in the beginning. Now is the Docker container, and then we connect with a database. The rest is just executed by themselves. Here I have a little code to create a GBDC connection and just start it. If you want to see this a little more after the talk, we have a little more talk, more time, so I could show you this all in live, how this is going. One thing is, finally, when you're working with test-driven, or you want to introduce in your project test-driven, don't hesitate, do it now. Maybe better today than tomorrow. You don't need any management permission. Just integrate the dependencies in your Maven or in your Gradle build and start write tests. That's all. But keep in mind, don't write a test for the whole application. Just for this code you're implementing, you're working directly, nothing else. And then you get rid of this terrible process, writing implementation, integrate exactly in your code base there in the UI, execute the UI. This is very time consuming, and there you find a speed up where you are, after you get a bit familiar, after 1 week, really, you speed up extremely your productivity in this way. These test cases, they are available, they are running. You get this information always when you do also refactoring and other things, code changes. You always see the application is behaving correctly without clicking through. Very important, keep your test methods compact, because you already see when you have there 100 line of test code and this is failing, you really have to investigate very long and understand the test code, why this is failing. So keep the topics compact in compact test methods and write more. And name the test methods in a way what they are doing there inside. No? Something like you were seeing for the RESTful service. No? There the 404 or the 500 error to find out what is the problem. And logging. Logging helps you really a lot to investigate when a test case fails, what could be the problem. So you speed up there extremely. And of course, test containers is a nice thing for having infrastructure. You don't need to take care about the setup. There we go a bit more closer to the idea. We have a build logic like Maven or Gradle, and every developer is able to use his operating system or EDI like he wants. If this is Intel IDEA or like me, NetBeans, because I'm working a lot with Maven. For Maven is NetBeans one of the best EDIs to write Maven POM files. Or if you want to work with Eclipse, everything is getting detected by your POM. And when you have installed Docker, the environment also will create it, and everything goes fine out of the box. You just have to run your build. That's all. Yeah, was all. Thank you for your attention. And if you have really some questions, wait until the record gets stopped. We will really be here a little longer, to show you more if you're interested. If you don't have that much time, you can find me on my website, elmar-.com. On GitHub, there is my repositories. You find me also in Twitter with elmar. Feel free to send me a message, and yeah. Здравствуйте. No, до свидания. No. Спасибо.
Thank you very much, Marco. Yeah, actually, we actually have some 5 minutes maybe still left for questions in this slot before we go to discussion zone.
Perfect.
And we have one question in our chat, and actually, Yuri asks about tools to provide test data for databases. This is quite an important one, I think. So do you use special tools to provide test data for databases? Or how do you just manage
And
it?
I'm working usually more into DevOps. So that means I'm not so in the development part in the projects. We are taking care about configuration management and testing databases. What we have there is something like Flybase, where we take care about the versioning of the database. Is a bit different. There's other tools like when I remind, well, Datadog or something where you really can increase a lot of data sets. But there's some online tools. I'm not so deep into this code generation or test generation for database. So every team I currently was joining, they are using different, how to say, different tools. Sometimes they was having own implementations because the data structure was too complicated.
Yeah, actually, I think this question should be discussed in discussion zone, because I have something to answer here. Because the company that I'm working at now really provides a tool for creating test data for databases. Just another question I would personally like to ask you. Of course, it's kind of eternal question. We always ask this. But what's your preference for, what are your preferred cases for Maven and for Gradle? Because you shown everything in Maven, and is it just a matter of what you know, what you prefer, or maybe you have some points about in which scenarios Maven is better, and maybe in some other projects Gradle is better? What do you think about this?
As first, I have to say, I'm not completely neutral in this topic because build management is a very huge topic. I'm there since decades. It was my finally my thesis in the diploma about Maven. One thing is I'm using Maven exactly for one reason, not because I know it, because it is like Java. Maven follows more educational path. This Gradle is too flexible. If you are as a build manager not consist, your build logic blew up and nobody is able to understand, like it was in the past with Apache Ant. So Gradle could mess up extremely because this don't force you to follow some rules. And another thing is, in my professional life, always the people ask me exactly this question for why we should not use Gradle. And then they always say, yeah, but we need here a build orchestration. And the point is, if you need a build orchestration in the way like to execute the first module than the other, there is a mistake in your architecture. Then I always recommend as first read the book Clean Architecture. Fix this architecture problem and you will not need Gradle and build orchestration. There is something wrong if you need that.
Okay. Yeah, nice answer, actually, very insightful. Yeah, and if we have time, just for another small, or maybe not so small question. I see that in your talk, you didn't mention Spring framework and all the tooling around testing of Spring. So did you do this on purpose, or just it's another topic for another talk, or maybe you don't like Spring?
No, I really, the code base you see there with in GitHub, they are based on Hibernate and Spring. It's really difficult to integrate as well your Spring context in your tests. So there you have to be a bit aware of it. There is some mistakes, and this could slow down some things too. And I was seeing there is a nice, interesting talk about how to be aware in your tests of the Spring context. Here at JPoint, I don't know as well which person it was doing, but he's coming from Mexico, Mercado Libre, a big company here, something like eBay. And he is talking about exactly about how to speed up Spring in your test cases. So this is one I want to join to see later.
Okay, cool. Yeah, thank you for the nice talk. Yeah, please, those who are watching us, please don't go away, because we'll proceed to discussion in a few seconds. Those who are watching us in recording, goodbye. Thank you for watching, and don't forget to rate this talk. See you. Bye-bye.
Absolutely. See you. Bye.